Good morning, everyone. So today we're going to go ahead and finish off the lesson that we started on Thursday. And let's go ahead and get started with slide number 3. It says, describe how the pattern growth and how many tiles are in figure 0. X represents the figure number and Y represents the number of tiles in the figure. So what does that mean? So this means that the X represents, the X-axis, represents the figure number, and that the y-axis represents the number of tiles in the figure. Okay, I want you to go ahead and pause the video before I give the answer. What do you think? How many tiles are in figure 0? So if we look at the graph, 0 is right here. So that tells us that there are 3 tiles in figure 0. There are 3 tiles in figure 0. So you would type that under question number 1. Now it's asking us, write an equation that represents the figure number x to the number of tiles y. Y equals mx plus b. Well, to figure that out, we need to find our slope and our starting point, or our y-intercept. So our slope, we don't know yet, but our figure 0, or our starting point, we know is 3. So this is the information I know so far in my equation. So there are 2 ways to figure this out. Let's go ahead and use a method we already know, a table. So I'm going to go ahead and do x and y. In figure 0, there are 3. In figure 1, there are 7. So from 3 to 7, I just add 4. So it's growing by 4 each figure. So y equals 4x plus 3, and that's going to be our equation. Now it's asking us, decide if the graph represents a function. If so, write the equation using the function notation. If not, explain why the graph does not represent a function. Go ahead and pause the video and pick your answer. This one is a function. If you remember, all lines except vertical lines are functions. So now looking at the next slide, it's asking us once again to describe how the pattern is growing. Our x-axis is our figure number. Our y-axis is the number of tiles in the figure. So, go ahead and pause the video again before I give you the answer. Figure 0 is right here. Although it's not labeled, we know that here is 0, 0. So if I go up, figure 0 has 9 tiles. So in number 1, I would write figure 0 has 9 tiles. For question number 2, it's asking us one more time to go ahead and create an equation. So we have y equals mx plus b. Remember, this is our figure 0, or our starting value. Let me go ahead and rewrite that. There we go. That sounds better. That sounds better. That looks better. Okay, so we already know our figure 0. How many tiles are in figure 0? That is 9. So let me go ahead and write 9. Try and figure out what number goes right here before I tell you the answer. once again, pause the video. Okay, so to do that, we're going to go ahead and use this triangle right here that was created on this line. What is this triangle trying to tell us? Well, this is the figure number, the x-axis. So every one figure, it's growing by 12. Every one figure, it's growing by 12. So I can assume in the next figure, it's going to add by 12, and in the next one, it's going to add by 12 as well. So that is my rate of change. So right here, I would write it as 12. And that's my equation. So does this describe a function? Once again, it's a line, it's not vertical, so yes, it is a function. Okay, let's look at the next one. It says describe, so same thing, okay? Describe how the pattern grows. How many tiles are in figure 0? X-axis is our figure number. Y-axis is number of tiles. So figure 0, always at the origin right here. Go up, see where it hits the line. Let's go ahead and count 1, 2, 3. So there are 3 tiles in figure 0. Now we have to go ahead and write our equation. So once again, we know some parts of our information. We know that in figure 0, there are 3 tiles. And this is how much we're increasing or decreasing by, or our slope, which is our fancy term for it. Remember, our slope. So let's take a look. If we do what they did in the last slide, we can draw triangles on this. So you can draw a triangle here, a triangle here. And what is that telling us? Well, from 0 to 1, that's plus 1. From 3 to 4, that's plus 1. So what is this saying? Pause the video. Try to translate it to yourself. Well, this is telling us that every one figure, it increases by 1. So our slope is 1. So is this a function? Once again, all lines that are not vertical lines are functions. Moving on to the next one. It says the graph below shows the line for a pattern tile. How is the line growing? That is, how many tiles are added each time the figure number is increased by 1? Explain how you found your answer. Go ahead and read that one more time if that didn't make sense to you. But basically, you're trying to find out the slope. Okay, what is the slope? Pause the video before I give the answer. So what is this graph telling us? It's telling us that every 3 figures, it's going to grow by 27. Every 3 figures, it's going to grow by 27. So how much is it going to grow each figure? Pause the video. Okay, so to do that, simple division, right? So 27 divided by 3. That's going to go ahead and give me 9. So I just simplified this. 9 over 1 is still the same thing as 9. So it's telling me it's growing 9 tiles every one figure. Now let's look at something that's going to explain what these triangles are. So it says the triangles in problems 2-13 and 2-14 are called slope triangles. I was trying so hard not to say this, because I'm an 8th grade teacher, so I've been teaching this for a while, and it's so hard not to call them slope triangles right away. So slope is a measurement of steepness of a line. It is the ratio of the vertical distance to the horizontal distance of a slope triangle. The vertical part of the triangle is called change in y, while the horizontal part of the triangle is called change in x. Note that the delta is the Greek letter delta that is often used to represent a difference or a change. So that little triangle there is what we call delta. What is the vertical distance change in y for the slope of the triangle? So I know this is seems kind of confusing, especially because they're using like Greek letters now. But let's go ahead and break it down a bit. So we want to know just the change in y, meaning what is this length from here to here? What is that change in y? That's all it's asking. So go ahead and name that change in y for part A. So if you notice, it changed from 1, 2. So my answer here is going to be that my change in y, equals 2. Oh, does not want to let me write 2. Equals 2. Okay, so for part A, you would put that the change in y is 2. For part B, it's asking you, what is the change in x? So the change in x is basically here. What is the length of change in x? 1, 2, 3, 4. So your change in x is 4. And that's what you're going to go ahead and put for part B. And that's what we call also our horizontal distance. Okay. Oopsies. For part C, it tells us draw smaller slope triangles for the line that have a horizontal distance of 1. Use one of these triangles to find the slope for this line. How could you use the change in y and change in x to find the slope of this line? What is the equation of this line? Okay, so quite a few questions. I'm going to go ahead and clear this so it doesn't seem as messy. So what they're basically asking you to do is find a slope triangle that only has a distance of 1. So, for example, this has a horizontal distance of 1. And you would have to go up. This has a horizontal distance of 1, and then you would have to go up. So let's take a look at this. From 2 to 3, that's plus 1. From 3 to, I would say this is around 3.5. That is only a 0.5. 0.5. Okay. So everyone figure it's only growing half a tile. So everyone figure it's only growing half a tile. So I would say that the slope is 1/2. How do we use delta and x? The change in y and change in x. Well, we know that slope is equal to the change in y over change in x. So if you're like, huh? What just happened? Well, let me explain to you. This change in y is 0.5. So our slope is 0.5. Our change in x was 1. 0.5 divided by 1 is still just 0.5, which is a half. Let's go ahead and try what we found last time. So we found that the change in y was 2. Our change in x was 4. So our slope, remember, is equal to our change in y over change in x. Our change of y here is 2. Our change in x is 4. 2/4 can be reduced or is the same thing as 1/2. So if you don't know, 1/2 is also the same thing as 0.5. So our slope is the same thing. Slope triangles are just an easier way to see how our line is growing. For this part right here, we would write, what is the equation of the line? Well, we know our slope is already 1/2. You can write it as either a fraction or a decimal. Mathematicians typically write it as a fraction, x plus, and now we need to figure out how many tiles are in figure 0. Well, figure 0 is right here. Go up, see where it touches, 2. So our equation is 1/2 x plus 2. Okay, so let's go ahead and practice this out. So we have slope equals change in y over change in x. So change in y is always how much you're going up or down by. Change in x is how much you're going from left or to the right. So it's asking you for part A to find the slope using slope triangles A and B. What do you notice? So we're going to find the slope of A and B. Pause the video. Try and find it on your own. Okay, if you didn't pause the video and you want a hint, here's your hint. This is the change in y. Remember, it means up and down. And our change in x, oopsies, is this right here. Pause the video once more and try to create the slope on your own. Remember, slope is change in y over change in x. So the slope triangle A, its slope is, in the bottom, we're going to have 4 because that's our change in x. At the top, we're going to have 6. 6 is our vertical change, and that's why it is 6 at the top. For our slope triangle B, our change in y is 3. Our change in x is 2. So our slope for this one is 3/2. Now it's asking us, what do you notice? What do you notice between 6/4 and 3/2? Go ahead and pause the video. Some of you might have said that 6/4 is the same thing as 3/2. It is only reduced, a fraction that has been reduced. So some of you might say that 3/2, in order to get 3/2, you just divide 6/4 by 2 in the numerator and in the denominator. So now let's look at question number B. What is the vertical distance? Change in y of the slope in triangle C. Explain your reasoning. So we want to know, what is the change in y for slope triangle C? Let's look at this. So I'm going to go ahead and, well, actually, I'll keep it. I was going to clear it. It went from 10 to, oopsies, not quite there, right there. So 14.5. So to get from 10 to 14.5, I need to add by 4.5. So my vertical distance is 4.5. Now it tells us to draw a slope triangle on the line with a horizontal distance of 1, meaning we want to change in x of 1. Find the vertical distance, change in y, of this new triangle. What do you notice? So let's go ahead and clear this stuff up. And we only want 1 unit. So let's go ahead. I'm going to pick, we'll stick with red. So if I go 1 unit, whoa, let's go back. If I go 1 unit, then what is my change in y? Well, here I'm going up by, let me just get a different color. I went from 4 to what seems like 5.5. So from 4 to 5.5, I added by 1.5. So this is plus 1.5. So my change in y is 1.5. So what do you notice? Remember, if I were to write the slopes of these once more, my slope of this new triangle that I created would be, change in y of 1.5 over change in x, which was 1. I forgot where my little decimal right there. So 1.5 divided by 1 is still 1.5. If you remember your answers from your others, remember we had 6/4. If you reduce that, that's 1.5. For B, we had 3/2. If you reduce that, that's 1.5. So no matter the size of our slope triangle, we still end up getting the same slope. We just sometimes have to reduce the fraction because 6/4 can be reduced to 3/2. And 3/2, mathematicians like to have fractions reduced to the fullest amount. Or you can change it to a decimal. It is up to you. Alright, let's look at slide number 9. It says, draw a line with a change in y of 0. How can you describe this line? Go ahead and pause the video, try this out on your own. You might be wondering, how am I going to do that? A change in 0. Well, let's imagine it. Let's say figure 0 has 5. In figure 1, it's still going to have 5 because it didn't change anything. In figure 2, it's still going to have 5 because it didn't change anything. And it's going to keep going and on and on and on and on forever like that. So a change of 0 means that the line's going to be a horizontal line. So it can be any horizontal line. It can be this line right here, or it can be this line down here. That's still a change in 0. So any horizontal line. Now it's telling me to draw a line with a change of x of 0. How can you describe this line? So remember, our x is our figure number. Sorry about that. So draw a line of change of x of 0. So how can we describe this line? Well, what this question is trying to get to is that we're going to get a vertical line. So it's going to look something like this orange line right here. And this is what we called, and we actually can't find the slope of this one. This is what we call an undefined slope. All right, let's look at slide number 10. This part is very, very important because a lot of students, when they're drawing their slope triangles, they're like, Miss Lopez, I don't know where to draw them. I don't know where to put them. This is what we call lattice points. These little parts where in the graph that these gray lines meet, these are lattice points. That's a lattice point. This is 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 a lattice point. You get the point. All right. So it's where the grid lines intersect, basically. So looking at this, look how perfectly these 2 points are on lattice points. That's how perfectly you want to draw your points, where they land exactly on lattice points. So you pick 2 points on the line, and then you draw your slope triangle. Okay, so let's go ahead and read this situation. So it says, Michaela was trying to find the slope of the line shown at the right. So she selected 2 lattice points, and then drew a slope triangle. Her teammate Cynthia believes that the change in y is 3 because the triangle is 3 units tall, while her other teammate Essie thinks that the change of y is -3 because the triangle is 3 units tall and the line is pointing downward. With whom do you agree and why? Okay, so go ahead and select with who do you agree and why. All right, so if you go ahead and notice, this line is pointing down. Let's say I was to draw my little friend right here. How we work with math is we always read graphs from left to right, just how we read. I don't read ECLL, right? I don't read ECL. I don't read this way. I read this way. Lattice. Lattice. So just how we read in English, we read from left to right in math. So imagine this little guy. Oops. I made him chubby now. So imagine this guy walking on this line from left to right. He would be walking down. Okay. So we agree with Essie that the change is -3 because this line is going downward. All right. Last question. So when writing the slope of the line, Michaela noticed that Cynthia wrote -3/4 on her paper, while Essie wrote -3/4. She asked, are these ratios equal? Discuss this with your teammate and answer her question. Go ahead and pause the video. So yes, they are the same. -3/4 is the same thing as the negative in the front of the fraction, and it's also the same thing as if the negative were at the bottom of the fraction. You just can't have 2 negatives at the top and the bottom because then this would be a positive. Okay, so this one is not part of it. All right, so now it's asking us to find the equation of Michaela's line. So looking at here, remember this is 1, 2, 3, but since our line is going downwards, our change in y is -3. Our change in x is 1, 2, 3, 4. So we can write our slope as -3/4, or how Essie wrote it, doesn't matter. And our figure 0 is right here. Let me see where it hits that line. And it looks like 9 tiles. So -3/4 x plus 9. And we forgot our y equals in the front. And there we have it, guys. We did it.